We're very privileged tonight to be hearing about the Melbourne Convention and Exhibition Centre and a recent upgrade that was done there for their audio and visual facilities. The Melbourne Convention and Exhibition Centre is a world-class venue. They appointed Rutledge Audiovisual to perform a site-wide digital signal processor audio upgrade, including global and local Dante networks, comprising audio, I/O, front of house mixing, paging, tie line management, audio over IP. Tonight we're going to hear about that. We're going to hear about it as an in-depth view of the system design, the functionality of that system, its operation, and the installation staging that is required when you're fitting out a live environment that's still running shows. Tonight we're very privileged to have Matt and Michael come along to talk to us. Matt is the National Operations Manager. Sorry, I'm talking to the wrong person. For the Centre, and for Rutledge, and Michael is for the Centre. So tonight I'd like to welcome them along to give us a bit of a talk about the Centre, and certainly at the end there'll be some questions. Make sure you get all the answers you can. I'd like to welcome you tonight. Okay. And thank you for coming along.
No worries. Okay, so welcome everyone. Thanks for the introduction. Mike and I will try and explain to you this upgrade, and maybe we'll go through a little bit of a background of how we sort of got there to start with, just as an introduction, and welcome to everybody. I was privileged to be involved in the original development, Melbourne Convention Centre development, which started back in mid-2000s, I think. I think it was opened around 2009.
2009.
Yeah.
June 2009.
So just to outline of the agenda, what we're going to go through tonight, we'll just talk a little bit about ourselves, Rutledge, what we do. Michael will chip in about the Convention Centre itself. We'll just look at the background of sort of how it got to where it was before the DSP upgrade, and then Michael explained, why we went forward with upgrading it, what the planning and what we actually did, what the solution was. So yeah, just a bit of background on Rutledge. So we're an audiovisual integrator, national company. 38 years in operation. We're over 300 staff. We're headquartered in Melbourne, but we have offices in Sydney, Canberra, Brisbane, and Perth, and Darwin, of course. Hopefully soon in Adelaide as well. So our business is structured in such a way that we have in each branch office a project team, a sales team, a project team, and a service team. And of course in Melbourne we have all our shared services, IT and HR, etc. So we're an Australian-owned company, and provide all services around design, consultation, full supply and installation turnkey. Whether that's digital signage content as well, we look at with digital signage systems. We have all our in-house programming, software engineer staff, field engineers. And just some of the other offerings, looking at IPTV head ends and now LED signs, which we're putting some into the Convention Centre extension. So, Michael, just want to give us a brief overview of the convention itself.
Melbourne Convention Exhibition Centre consists of two current buildings. One is what is affectionately known in town as Jeff Shed. The exhibition centre. It's got 30,000 square metres of pillarless exhibition space, and as we were talking about, the Melbourne Convention Centre, which opened in June of 2009, which comprises 32 meeting spaces as well as a 5,500 seat plenary hall. The plenary hall, where we say it's multifunctional, it'll break down from 5,500 seat theatre down into three venues, 1,500, 2,500 and 1,500, each of which can run simultaneously as long as you don't turn the subs up.
Yeah.
But no, it is primarily a convention centre, so therefore for vocal reproduction, the rooms are acoustically isolated from each other. The only time we do actually have cross audio between the rooms is when you have a lot of sub bass running through the building, and I think that's more to do with the concrete.
All right, so we'll just get into a bit more detail as what Michael started to explain then around the plenary hall. Plenary hall obviously divides into three. Each has its own motorised projection screens and front of house PA. The seating is configurable. The floor, and I don't know if many of you have been down there, is motorised, so you can change the configuration to full seating or flat floor for tables. There's a banquet hall that is dividable into two. It's a very flexible space used for all sorts of...
we do exhibitions as well as dinners. We do small concerts as well as large lectures. In a dinner mode, it'll sit up to 2,500 people for dinner with a dance floor and a stage for entertainment.
So then we have meeting rooms which have fully fitted out audio-visual. These meeting rooms are able to be user-operated. They obviously also have the capability that they can have a tech to run these rooms, but they do have a lectern with a fully functioning control system that the user can just run their slides from the lectern. It's sort of similar to the way I'm doing this now. And they have a PA system, projection, obviously sound reinforcement, lighting control, everything you would expect, for example, in a university teaching type environment. That's all there ready for the convention centre to sell. So there's a couple of different sizes of these types of rooms. They have the large meeting rooms are combinable, so you can join two of those together to make a double-sided space. Then down to smaller type meeting rooms that are a bit more of like a boardroom space. They have a flat panel on the wall rather than a projection screen to use for much smaller meetings. Surround sound, obviously audio, I think. They originally did have some video conference capability,
yeah, I think. We did have the video conference capability, and then we realised we made our money out of people coming to us.
Yeah. So that was... yeah, so obviously there's a back end to all these rooms, and the way the convention centre is structured, there's 3 satellite control rooms where each room will have a rack of equipment to drive that room. That provides their techs to be able to get in the back room and repatch inputs, and obviously resolve any issues without needing to get to the room itself. And they're stationed fairly close into groups of rooms, and also provide an operator to actually monitor what's going on in the room. They've got little video monitors for each rack, and there's also a station where they can go and listen and view sort of at a desk environment in that satellite control room. Satellite control room also contains the switching, so all the IP switches and patching for that area. And also you'll see this rack here is all of the Bosch Presidio amplifiers for the combined PA and EWIS system, which is for that area as well. Not only for the actual meeting rooms, but all the back of house areas in that vicinity. You'll see down bottom, this picture is of the previous DSPs. You can see these units there. You'll see them shortly on another slide. So the master control room is sort of like the nerve centre, I suppose, where techs will monitor what's going on in the whole Melbourne Convention Centre. You'll see up on the wall there's LCDs with images of what's going on in various different rooms. Some obviously haven't got the lights on, so they've been blacked out. You can see one of the divisions of the plenary up on the top monitor up there. So those guys are there to monitor the day-to-day activities and understand it, be able to go and diagnose issues. They can remote control those rooms from in there, and just sort of generally monitor the activities daily. Main server room, so apart from the master control room is just like an operating room, but the main server room is where all the the heart of all the central equipment goes. So there's central video routing, central DSP, IPTV head-ends, and the like, digital signage head-ends. So speaking of, throughout the convention centre there's digital signage to help assist with wayfinding, indicate what event's on in any particular room. You know, if you've been there, you've seen the large LEDs which have the listing of the daily events. That's all run from the central digital signage, which is pads.
One of the biggest things about digital signage in the centre is it's a very, very large facility, and we have to treat wayfinding and guiding people through it as if you were in an airport. We're actually guiding people in their thousands on a daily basis to try and find any one of 45 different rooms throughout the facility. So we have the LED walls, we have the digital signage with the event information, and it's all designed to be able to get you closer, 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 and I'm here to a space, rather than individually tailored, because we're dealing with people in their thousands.
And of course, all part of the audio system is the facility-wide EWIS system, so that doubles as being obviously there for evacuation, background music, recall chimes to return to your room, and throughout all the meeting rooms, it's actually the sound reinforcement for that individual room as well. Okay, so we'll just quickly go through it. So, 2009, the convention centre was open, and not too long after that, there was a refurb of the AV systems in the existing Jeff's shed. So the MEC had some upgrades with meeting rooms, a satellite control room as such, because previously it was more, I suppose, just connected equipment in portable racks and so on.
Front to back patching only, and there was no central rack-based system with distributed audio. You'd bring in a PA on wheels, put a console at the back and run a loom around, or patch through the wall front to back in the old system, and didn't have that integrated vision, audio, DSP, and integrated with the rest of the facility.
So during that process, then we connected that back to the convention centre so they could monitor and monitor from the same central location of the convention centre. So there was obviously additional digital signage in there, the PA, and obviously that is where the exhibition halls are contained as well, which is now connected, or being connected back through to the site-wide system. So that, I suppose, goes through the existing facilities of, I suppose, the Melbourne Convention Centre and the previous exhibition centre with upgrades. So since then, due to the timing around 2009 when the Convention Centre was opened, it was just in the, I suppose, transition phase from analogue to digital. So while we held off as long as we could, the video routers that we put in there weren't quite what was needed for the centre going forward. So I think in 2014 we did a site-wide digital video routing upgrade, and combined with that we did fibre cable infrastructure upgrade, where not only did we have fibre backbone, which was there previously, we went fibre all the way to the room, so all the way to the point where you go and connect your lectern. We put fibre infrastructure in for that. And at the same time, we also looked at touchscreen upgrades to newer models, and I think also some user interface upgrades and improvements with the software too, isn't it?
Because we do expect our customers, if they do not want a technician in the room for a simple presentation, they drive it themselves off of one of our touch panels in there. If you have a look at the picture there, that's actually a photo of one of the original model touch panels we had in there, and you can see how busy an interface that is. And so part of the work we did in the upgrade was to have a simpler front page user experience with the ability for them to tab over to another page so they can drill down into more depth. If they consider themselves an expert user, we didn't remove any functionality. But if they were just there to say, I'd like this picture on that screen, please, it was literally simplified to the push of a button.
Okay, so just a bit more background, I suppose, specifically on the DSP. The original DSPs were AudioFlex, manufactured by Biamp. I think there were also some XPs and Expos, which are a small, just a breakout box. The protocol was Cobranet, so that was run around on the converged Cisco network. There was also Bosch Presidio network, or two actual networks to run all of the site-wide PA and EWIS. Within the plenary for the performance systems, we had EtherSound, but that was primarily around connectivity to the Nexo equipment we had in there. So that's what was in there prior to looking at the upgrade. So I suppose that's where Michael had a look and on his team about, well, what do we do going forward?
That's right.
Yeah.
Thanks. So one of the things about the facility we have here in Melbourne is not only is it large, it's also very, very highly utilised. We have been recognised internationally as one of the most technologically advanced spaces in the world, but we run and we run hard. We do over 1,000 events per year, and that includes over the period of our shutdown, we actually achieve something like an 82% occupancy rate in there. So anytime we're working in that space, we are turning those rooms over from one event to another overnight. Customers coming in the next morning, ready for their show. They leave at 6 o'clock, we're turning it around into the next. In the plenary hall itself, we also operate a lot of concerts, dinners, evening events, flipping over into a conference in the morning. So speed and accuracy of turnaround is critical for us. We get over 1 million attendees through the building over the course of a year, the majority of whom are either international or interstate visitors to Melbourne. And the control screen upgrade is to allow us to control those spaces, including all of the audio routing, as preset automatically as possible. The reason why I'm emphasizing preset automatically is because we're repeating similar configurations over and over again, where the seating line, the stage line, and the PA lines are fixed in space. We can recall very complex presets over and over and over again to achieve the same result. And then, of course, you need the ability to go into the DSP for that one time in 1,000, where you actually do need to change your 0 point on the PA or move your delay line. As Matt was saying, the previous system, and the system that served us very well for about 8 or 9 years there, was based upon the Cobranet protocol, and it was the Biamp AudioFlex system. Cobranet is a distributed audio system carrying all of the audio packets, if you like. I think they use the term bundles in Cobranet world, permanently on layer 2 of the IP protocol, which means it's all sitting there simultaneously. Now, as Matt was saying, we've got these large meeting rooms. One of the things I'd like to point out here is we have what you're looking at here is a large combined, so the wall is out. We have our Nexo front of house systems on the front wall, and we have our distributed audio systems up here in the air. One of the other things these rooms do, and I'm going to try this clicker, see how fast I can go back, because I saw a great slide of Matt's a moment ago. I'll get there. Okay, so here we go. The rooms also rotate. So we turn that projector pointed that way, the screen up in the air there comes down, and we're now using this PA on this wall. The distributed audio system now, I won't use the term rotates, but we have a pad across the stage end. We rotate it so the pad is now across this set of walls, and we can turn the room around within about 10 minutes into facing the other direction. And our customers, A, appreciate, and B, expect that level of flexibility. So our DSP, whatever solution we have, has to handle the ability to manage all of those different inputs into all of those different outputs and achieve them reliably every time. So why did we want to change? CobraNet had some limitations. It sits on IP layer 2, which means all of the data is permanently sitting available and, if you like, accessible to each DSP in the network simultaneously. What that meant in practice is if there was an unexpected power outage or an unexpected loss of integrity to that network purely by, say, what do you call them? The backup system? UPS. Thank you. Sorry, lost it there. Falling over in one of the rooms. It would not just take out that area. It had the potential to propagate that error through CobraNet and send remote DSPs into an error state, no matter where in the two buildings they were. Which meant we ended up having to have a training regime with our crew. We had a code word that you'd shoot out over the radio, which was basically drop everything you were doing, run to your local satellite control room, and reset the DSPs. We've just lost audio everywhere. It was just an inherent limitation to the CobraNet protocol and how it was reacting to such a site-wide, large number of rooms all sitting on the network. So the user experience from the end user was try to explain that to the customer sitting in the room, why there wasn't even a power outage in their room. It was a kilometre down the other end of a corridor somewhere, and yet it propagated an error through to their space. We got really good at resetting those expos really quickly.
I must say, it's not limited to the convention centre either. We've had numerous issues in the past to the MCG as well with that sort of similar problem. As soon as you get like a flagging port on a switch, it can affect the audio site-wide.
And it'll propagate out through the network. And it's inherent to the fact that CobraNet's a layer 2 protocol. Now, that is what we had available to us in 2008, 2009. So, obviously, from a business perspective, was it stable? Was it reliable? Well, I've got to say 85, 90% of the time, yes, it was. But it was the 5%, 10% of the time that we needed to nip in the bud. And the fact that we actually had an emergency call signal for the techs didn't always fill us with the greatest level of confidence. So what did we want? We wanted stability, and we wanted a redundant network architecture with either self-healing loops or isolated network ports so that we could, if we lost a room, power outages can happen, a UPS can fall over. If a power outage happens, it's only really affecting the local space. There's no single point of failure that can pull down the entire network. We've all been in a situation somewhere where a power supply is fried, we've lost a bit of kit, we move on with our lives and off we go. We didn't want something that would pull down the entire network and the entire facility. We are a multi-use venue. Like I was saying, in the plenary and the banquet space, we have high-end entertainment, we have rock and roll concerts, we have community-based Chinese, Indian, multicultural concerts coming through on a regular basis, and we're a lecture hall. So what we wanted was something that would work both in the corporate install AV environment and something that would also support 96 kilohertz for the high-end audio users of the plenary hall. And something that we could use across a wide variety of manufacturers' equipment. We are a Digico house. However, we're also a destination venue for touring companies who can bring in everything from an LS9 through to the Avid consoles. They'll bring in their Digicos. Whatever protocol we needed to be able to interact with a wide variety of consoles. I think this is your bit.
Yes. So, obviously, Michael's explained, there was a drive for change. So, they went into a process by which to investigate the options. And we answered an RFQ and were the lucky recipients of the contract to upgrade all the DSP. So obviously it was going to be a difficult installation due to the fact there's a live environment, and Michael explained how busy they are and how difficult it is to get into spaces. due to their booking schedule. And obviously we weren't going to be able to lock down whole areas or whole control rooms at any one time. So it was going to be a difficult and I suppose protracted upgrade, of which we are still
in process.
Still in process, albeit we're probably 80 to 90% of the way through. I think this is
about that.
As an estimate. So I suppose what Michael's team did was in around 2014, 2015 was have a look at what other manufacturers kit was available, what were the protocols, and that's when they decided to go down the path of the Harman BSS running on a Dante platform. Dante platform is obviously very interchangeable with lots of brands of mixing desk and
that's it. Because Dante is a proprietary protocol licensed out by Ordinate, in some ways people can find that a little bit daunting, but what it meant was that there's a much wider range of console manufacturers who've picked up, or audio equipment manufacturers who've picked up and run with it. So we can go out to market and we're not restricted in our console usage because pretty much everyone has Dante cards available at a price. We did investigate at the time, as Matt was saying, we did some research with AVB, which I believe is now called TSN in the new nomenclature. But one of the difficulties we found with that particular protocol at the time is it wasn't Cisco compatible. And as Matt said earlier, we have a converged Cisco network, and AVB wasn't playing nicely with Cisco at the time of the upgrade as we were putting together the specifications. And also, it's not a protocol that's available on a professional audio console.
Yeah, so our engineers, combined with Michael's engineers, worked very closely in the planning stage to come up with the technical solution. And I suppose, that was a very close collaboration. Obviously, they had the concept, and then we came in and helped them refine it. So, the plan, obviously, just discussing before, the plan around the bookings and how we were going to get into rooms. What it meant was it was going to have to be a staged implementation. The only caveat on the rooms was instead of we could not just do one room at a time where we had link rooms. We sort of really needed to do the two rooms that were going to be linked together. But obviously we needed to maintain the central services so they could still monitor everything from their master control room. So you could still get BGM piped throughout. So we had to do some duplication there where BGM would be going out on Cobranet and out on Dante. And obviously it was a very strategic planning with the project management and scheduling staff of convention to try and work out when are we going to do the rooms. And I think in the end we did maybe 2 or 3 at a time, something like that. 2
or 3 at a time, staggered out over a week at a time. Then we might have to take 2 or 3 weeks off while we were in an incredibly busy period, and then come back in and do manageable chunks in and amongst the event schedule. And I worked with our salespeople saying, well, can we not sell these rooms just for a few days while we move them over here? And we did a bit of shuffling of clients.
So we had to get in there and decommission the audio flex. So that's the obviously the back panel shows a bit of an idea what the I/O was there. Fortunately, it wasn't dissimilar to the selected BSS hardware, albeit I think there was some rewiring and reversing of connectors.
Pin 2, pin 3.
Bit of swapping here and there of wiring, but I think usually the techs could get through one of these in about half a day of wiring.
Yeah, about that. Yeah.
So that's the Blue 806, which has the I/O and the DSP incorporated. And that's the Blue 326, which is basically a breakout unit. So it doesn't have DSP in the box, but will take streams coming through on your Dante and your Blue Link and feed them either in or out via the connectivity there. So that's basically, it was a box swap, I suppose, or a 1 box to 2 box swap, because in most of the meeting rooms there was a 806 and a 326. So I suppose the high level of it was that we were changing over to protocols on a similar topology because the network was still in place. We were going to something that was the latest IP protocol. It was still going to integrate with the EWIS system, but would increase the flexibility and give them the capability to plug a mixer in digital land in the meeting rooms, whereas prior to that it was more around an analog patching exercise. Okay, so this block diagram might be a little bit difficult for some to see. It gives you a high level view of what we implemented. This is a typical meeting room. So as I was saying, it is an 806 and a 326. So this one has a DSP in it. This just provides expanded I/O capability. Now within a control room, we've connected via BlueLink. Now BlueLink is BSS's proprietary protocol for connecting their boxes together. So we only use that within an actual control room, and that was primarily used where you had to link rooms. So if you had one rack and then the next rack together, when the two large meeting rooms are combined together, the audio would pass from one room to the other via the BlueLink.
Now, one thing I just wanted to mention about BlueLink, this was one of the killers that brought the BSS into our world, is that BlueLink is a self-healing network. It's two cables across. You lose any part of the money hop around the network, it'll come back the other way. So, again, as part of that redundant network topology, it gave us that.
Because it's basically a ring topology.
Topology
so
on that.
You cut it anywhere, you've still got connectivity.
You've still got connectivity.
Yeah. So the other key thing that we looked at was having a local and a global Dante. That was really critical around isolating anything that was connected in locally in a room could not affect any other room around the venue. And the way we did that was we were utilising two completely separate Dante ports in the pair of DSP boxes for that particular room. Now, the reason why we wanted a local Dante VLAN was so you can go and plug in your mixer and whatever other devices you wanted to connect into that room.
That's why we got a Modus M32R console. It's on wheels, bring it in. Rather than using half a dozen analog patch cables, XLRs, to connect in and out of the DSP, it's one bit of Cat5. And we've got full control over the DSP and can replicate all of the audio local to the console over the network.
And previously, and still is the case, we have all of the I/O in each of these boxes here to connect microphones from lecterns and so on. Well, that can be put onto that local Dante network, sent out to the mixer, manipulated and mixed there, and then sent back in again to the DSP for distribution to the local audio system. So the other connectivity, there was the other IP connectivity was the control room AV LAN, and that's around connection to the AMX for control of that DSP. Because obviously you have a touchscreen where you've got volume control and you've got routing, etc. to what you might have source, replay, etc. So that provided the control strings with the red lines there. And then this brown one here is the global Dante. So what that enabled MCEC to do was run their monitoring feeds back to, and we'll go into that in a little bit more depth, and obviously provide BGM feeds into that room, and I think recording, all those sort of additional functionality that a site-wide IP would allow you. So here, that's the recording part of it, which is in the central server room. So this is a feeds over to the exhibition centre, so you can page out to there, BGM out to there. And this is the so this would be the main control room, monitoring, etc., etc. This area here is the plenary. I think I might have another slide showing the plenary a little bit more detail later on. But basically, the plenary is slightly different in that there's a third type, I suppose, of Dante network where it's running at 96 instead of the rest of it's running at 48. Yeah, so basically, yeah, just a summary of what we were just talking about: the local Dante, the global, the performance Dante network at 96K, and how it's all been isolated. So, yeah, within a room, these are the audio services that provide. Obviously, there's a front of house audio, there's ceiling system, front of house left and right, digital audio tie lines. Obviously, you can provide from via the Dante. The other service being recall chimes. Okay, so a little bit. Now we're getting a little bit more detail of what happens in each room and each DSP. So this is a room where there's an 806 and a 326. So you can see here's your mics being patched in. Now there is more mic inputs in the room, and they go up to a patch bay. So there is the old, XLR clunk clunk to connect in. So some things never change.
Yeah, that'll never change.
There's a radio mic receiver there connected to it. This is the output of the switcher. We talked earlier about the video upgrade. So that's where the audio comes from, your source audio. Your blink, we talked about that, how that connects to the other DSPs within that local room to be able to link to another room. There's your global Dante connection, your AV LAN for control, and here's all your outputs. So you've got an encoder where you've put video and audio onto the IPTV. You've got local control room monitor. You've got hearing augmentation, front of house left and right, and ceiling zones. So you see there's 1 to 4 ceiling zones. So that's what Michael was talking earlier about zoning.
Rotating the rooms, we can pad a channel of the amplifier. We can keep the rest running at 0, then rotate it and switch the pads around.
And down there's your local Dante. So you can see we've utilised the two separate Dante ports on the 2 different DSPs. Okay, so it's a meeting room. And this is just talking about the banquet hall. Banquet actually is a little bit different everywhere because they've got their own racks in the rooms. So the blue link actually transfers from one room to the next room. Yeah, link those together.
The 2 racks are about 30 metres apart,
yeah,
but they're identical in functionality and they work the same. It can combine and separate and rotate.
So that's the banquet. Now plenary. Plenary is a little bit different in that the performance requirements requested were to run the performance systems at 96K rather than 48K. So what we had to look at is, trying to isolate those because the clocks would not be compatible running the DSP at, or you just couldn't run the DSP at both clock rates. So what we did was separate them out. So you can see the orange line here is the Dante to get into the plenary from the central. So that's got the audio going to and from the central DSP. And then the red here is the local 96K Dante network. What we did, we used this sample rate converter, Orvitran, so to convert from 48 to 96. So this unit here was taking was converting the local feeds to and from to be able to send it back to the central DSP. That then meant it was compatible with the Digico rack and Digico consoles to run at 96. And what we did then was use BlueLink to run out to the amplifier rack, so the Nexo amplifier rack, which previously were delivered via EtherSound.
Yeah.
And now these, I think we might have another slide showing a bit more detail. Yeah, so you can see in the plenary hall how the BlueLink links around between the different halls. So obviously sometimes they're divided and sometimes they're all combined. So it gives you a bit of an idea of how the 96K local Dante distributes the audio within the plenary. So this is the racks which are up in the dimmer, well, not in the actual dimmer room. They're actually up on the tech grid above the Nexo stacks there. So next, we've just got a bit of a high level. This is the DSP internal config of one of the meeting rooms, one of the satellite control rooms monitoring configuration. So all of this is actually in the central DSP. What we're doing there is sending all of the room's feeds to central, where it's routed here and then sent back to that satellite control room to be able to be listened to and selected from that control room. So just an example of some of the DSP configuration. The next one's a little bit more difficult to see, but this is actually a room's DSP. So there's a fair bit going on there, and obviously you've got input blocks, then some processing, routing, output processing, and then sending off either to back out to Dante onto the network, or out analog to drive your front of house and ceiling systems. Just on the ceiling systems, probably haven't mentioned that. I think we talked earlier about how the ceiling systems run through the site-wide PA. Well, these outputs here go into inputs of the Bosch Presidio locally there, because the Bosch Presidio, because of that, needs to take priority, and that's actually what drives all those ceiling systems. So this is one of the rooms, room 107. Okay, so just now talking about this is more about, well, where are all the feeds going from and going to, or why are we doing a site-wide DSP? So the network Dante obviously provides connectivity between boxes, not only in that local room but into the central. It provides paging from the paging microphone at the reception desk, provides the output to licensed PCs where they can pick off channels off the Dante in those PCs to be able to record. This is where the master control room, I think I showed you earlier, that's where the techs sit and monitor the whole facility. They can take any of the feeds from any of the meeting rooms and listen to them in there. The EWIS integration, I think I spoke to you about. There's a number of channels. I think it's 4 channels that you can send from the site-wide DSP into the EWIS system, and then the EWIS system has a control system such to tell it where to send those IP feeds, those audio channels. This is the central routing, so there's 3 DSPs in the actual server room, and what they're doing is they're the heart of the whole system as far as routing of audio between areas. I talked just before about how you can route back to a satellite control room to be able to listen to what's going on there locally. And this one here, this is the DSP that actually receives those global Dante channels coming back, and actually just sends it out to local headphones and speakers to listen in the satellite control room. And obviously with room overflow, if you want to, if you have an event going on, I suppose you might want to explain how the overflow and how that gets used.
So if you've bought a room, come to do a conference or a lecture, it seats 120 people. 160 show up. What do we do? If we have another room available anywhere in the facility, we'll quite happily sell it to you. And in order to achieve that, we need to route the video and audio to that room, regardless of where it is within 60,000 square meters of space, and get it there before you get there. So that's where our room overflow is. We're able to, in the master control room, fire up a room, turn on the PA, the projector, and route the audio and video and live, whatever's happening in the room live, either on the live console or on the automatic DSP over that space.
So we talked a little bit about the redundancy. obviously the network itself has, the Cisco converged network has redundancy built into that. The BSS has a central server, it's called a Contrio server, and what that enables you to do, it has a self-healing function. So, for example, if any of the BSS boxes die, you can take that one out, put a new one in, and it will gain its configuration from the server automatically without having to go and individually connect to that box and load in its configuration, because it'll know which one it is. Blue Link, I think Michael explained a little bit about the ring topology there. So in some areas we're using that. So if there is, for whatever reason, one unpatched or cut or disconnected, the audio will continue. And I think, yeah, basically all of the configuration across the site is pretty much standard. And it's just a matter of, well, in some areas it uses some of the blocks and not all.
Yeah. We try to keep everything as standard across the facility as possible. We have a lot of rooms and a lot of space, and we also have a lot of technicians. And to try and keep everybody consistently across where we are with all of our upgrades, we try and standardise your experience as an end user or your experience as an audio technician in each of those rooms, so that you're not going to hit, oh, I'm in room 107. What did I have to remember about this space? Oh, I'm in room 205. What was different about this room? It's all standardised across the facility.
Yes, as mentioned, the main usage of the Contrio servers is self-healing action. It has logging. The other part of it too, it'll be utilised for replay of media such as recall chimes and
background music,
automated messaging and so on. And leave your bag unattended and what have you. So those sort of that sort of messaging. Okay, so just sort of to wrap up, basically what they were looking for was a standards-based network. So as more and more products come online, in general these days they have a Dante port, so that provides more flexibility for new audio devices to be plugged onto the network, and obviously giving that site-wide, I suppose, capability for overflow and.
Well, that's it. And we're, I don't know if everybody noticed the cranes over the back of the Jeep building here on the corner, but we're only getting bigger, and RutledgeAV are helping us in doing the integration of our new facility. You can't get rid of me, Matt.
No.
I don't know how long we do this. And so standardising our approach in stage 2. Yes, we have new technology available in the audio space and in the video space, but again, taking advantage of the new technology, upgrading. Like in terms of vision, we've got 4K, we've got laser projectors, we've got higher bandwidth signal, but it's all based on the same design principle as what we've gone through here. And now with a much bigger foyer area, much bigger paging requirements, much more space to cover. With the BSS system, it's pretty much build more of what we have, please, and make sure the processing power is there to drive it, but it's just give me more to cover a wider space, standardised approach,
and
plugs in.
Doing those upgrades over the last few years has made it a lot simpler when it's come to the extension, because MCEC has already looked at, well, what is the next step? What is the new technology we need to move to? So it made the design process of the extension far easier than would have otherwise if we were sort of starting back at 2009 technology.
Yeah.
So.
The company does invest a lot in technology, but not just in hardware. It involves in people who know both our customers and the tech that drives the product that we offer them. And working in partnership with a company like Rutledge, we're able to start working years in advance of a capital project and start saying, well, where is technology going to take us? I'll catch up with these guys at various international conferences saying, oh, have you been to the Bosch stand? Have we caught up around what's the new Dante management system is going to be? And we start looking at what those technologies are that are coming out in the future. So we know where the convention centre is going. We're not having to leapfrog. Step by step, make sure we stay at the forefront of technology. So when we do whack up another building, we're not reinventing the wheel. That's it. If anyone has any.
Okay, questions? I have one. Oh, we have two in the front. From the left to the right.
Just on the reliability side of things, because that was one of the key drivers of the change. Can you give me some background, with regards to the improvements in reliability that you've been able to achieve? There's certainly no site-wide dropouts.
Has not been a site-wide dropout since we've implemented the
that
meetings.
much, and that's great. But just in terms of single room, activities or multiple rooms that you might, how is that?
The single room and multiple room reliability has been there. The one piece of the project that we are still working on together is Dante uses a naming protocol in order to identify devices that it's connecting to. Because we do not have a console per room, when we bring in our portable consoles, we're not renaming the console or renaming the BSS Dante network to say, this is your device today. We're going to pick it up, we're going to wheel it into another room, plug it in and expect it to play. We're still working with BSS on a piece of firmware that's going to go in there and tell the Dante, the processor, I don't care how many times you turn off and on again, don't change your naming protocol, please. We worked all of that out as part of the initial design piece, but then what we found is when you turn it off and on again, it resets the name. That's the only piece that we found. I wouldn't even call it an unreliability piece because it doesn't affect the customer. It's our crew, when they wheel it in, now have a part of the protocol when they set it up to check the naming protocol.
It's not a bug, it's a feature.
That's right, exactly. It's more flexibility. That's what it is.
Okay, thank you.
Graham.
What have you done facilities for the hard of hearing?
Well, there's infrared throughout. I think we've just reconnected to the back to the output of the.
So we've, with all of the reduction in the unlicensed bandwidth over the last few years, we've moved from an FM hearing aid transmitter system to an IR-based hearing transmitter system. I don't know if you noticed, all the walls are white in those meeting rooms, which means you've got excellent reflection all the way around the room, and no matter where your receiver's sitting, you can pick it up. So that, it was part of the project scope.
Separate system for each room.
Each room has a separate system. Each room has a wall, and walls are really good at isolating systems when they're light-based from each other. So the plenary hall has 4 IR transmitters per divided space. And then part of the BSS project is how do you then link 12 Williams IR transmitters back through to an output of the BSS system without having any latency issues bouncing around the room. But that's something that's tested in the model. The plenary hall is actually the last part of this project to take place. That's currently scheduled for January. Reason being, we can't stop selling it. So we haven't been able to give Rutledge the time to get into the space until January to do that room. It's one of the more popular rooms in Melbourne. But no, hearing assistance is, it's part of our responsibility as a venue to provide hearing augmentation services throughout every space.
Thank you.
You didn't talk about the user interface development. I believe Rutledge did work on developing the user interfaces for the controlling centres and the rooms and the customers.
Yes.
Can you talk a bit about that, please? You can say no.
No, it's not actually part of this project. It was done as part of the digital vision upgrade project we did in 2014. I might just skip back a couple of slides that I noticed didn't. So this is the user interface you're referring to here, which is the AMX panel, the AMX control system. So the system allows the user at the lectern to control volume levels, both and separately, their microphone fleet. So you might have, say, 3 head tables over here. I might be wearing a lapel mic. We could be standing at a lectern. Any combination of both condenser and dynamic microphones. The customer gets to control their own volume. The DSP then handles, in the back end, level balancing, and our technicians will pre-set all of those prior to the event. Switching of video sources, you might have your laptop sitting here on the table. We provide an inbuilt desktop PC in that rack, so they might load something on at the lectern via USB and have their own laptop, as well as playing a DVD or a Blu-ray disc. And so it provides all of the control interface over that, as well as the ability to balance your volume from the different sources you've got coming through. As I said earlier, all of those sources are coming through those Nexo speakers on the back walls of the meeting rooms, whereas your voice reproduction through the microphones is going through the distributed system overhead. So we don't have any real issues with the gain for feedback because the speakers are behind your mics, because we're only pushing the microphones out over your head. Other facilities there, like that page there, happens to be on the IPTV box, so you can actually flick around the TV stations depending on the nature of your event. Some of our meeting rooms are used as organisers' offices, so the committee who's running the event might have a boardroom table in there, and they might be running, I don't know, a security conference about security protocols currently. So they might have ABC News on, watching a particularly pertinent topic. So free-to-air TV is part of the service offering. Background music, again, that's being fed through and off the DSP, so the customer's got control by hitting the background music, which of 4 channels they might want to listen to. There's a variety of jazz, corporate, pop music, and classical that they can select based on their preference for their event, and again, separate volume control for there. The interface was basically a refresh. I'm just trying to find, I saw it pop in before Matt, the old panel. There it is. Yeah. That's the old panel before we did the upgrade. And one thing we don't actually show, I haven't seen come up in the slideshow, as I mentioned before, the interface here and in that other one I was showing earlier is quite busy. And we didn't actually, there's no slide here to show it, but now we have a front page on a separate tab that basically has 3 buttons: laptop, rack PC or DVD, and microphone volume and source volume. And it's just, it hasn't limited functionality because they can just hit the other tab and go into the full depth and detail. But when we introduce them to the space, we leave it on the simple panel. And one of the most popular buttons, if you'll see that little lifesaver icon there, Master Control Room, we've mentioned it quite a few times, as to that's where our technicians sitting monitoring activities throughout the building. If you hit that button, it'll ring, it'll log a help request in our RMS feature. We will radio a technician to come and attend, help you get through to the next piece. And part of the entire system we've got is the AMX system will then record the call, take a log of anything that is unusual happening on the network at that time. So it's reporting back any network connected devices back in. It'll take a snapshot of that, and we have a free field to enter text as to why did we call a technician to the room. What that means is that if we're having ongoing issues in the spaces, if one room gets a lot of calls, if one customer is very needy, if we're seeing similar issues, say channel 4 audio input into the DSP seems to be causing a lot of issues in that space, our systems engineers are starting to see a pattern there. We're recording the data, recording the pattern, and we can send somebody up to look at a rectification piece. But when you ask about the user interface, it's the AMX.
Okay, that was done separately from Rutledge.
No. Rutledge did this project as well.
Okay.
We, as a government owned, managed facility, we're very, very much beholden to the Victorian government procurement process. I've learnt that phrase very, very elegantly, which means for any large project over a certain value, we must go out to open market. We can qualify that based on the complexity of the project and requirements for technical expertise. However, it's still an open market tender. Rutledge Engineering, now RutledgeAV, we've been working together for quite a while, have been successful in the tendering applications for the build of the convention centre project, the upgrade of the Melbourne Exhibition Centre, the Vision project of 2014, and now the Audio DSP. And I'd like to say one of the reasons that Rutledge has been so successful, they listen. When we send out a tender brief, what I'm looking at coming back to me as the person who's going through that tender brief is that they've actually gone through and read the technical specifications that we are trying to achieve by performing the upgrade project. And these projects are not small change. They are quite extensive. And I want to make sure that my end customer is going to get the best result out of this, which means I need the respondent to those tender documents to actually demonstrate that they have read and understood the requirement. And in each of the tenders that I've been a part of, Rutledge have excelled in their response back to the formal tender process because they've managed to demonstrate an understanding of what our customer needs. I'm only there to service the customer. That wasn't an paid advertisement. Sorry.
What role does optical fibre play in the network links? It seems to be mostly Ethernet or proprietary over Cat 5.6.
So all of the satellite control rooms are linked via fibre back to like a normal IT network would.
Right. Is that on the BSS system?
On the so all the BSS. So basically, the Cisco switches have fibre uplinks that connect them back like a traditional network. Yep. The fibre to the room was more around the digital vision upgrade, so we could actually get the highest bandwidth as possible for the video, all the way to the video projectors and to the lectern, basically. So almost to your laptop, pretty much from your laptop all the way to your projector.
To the projector, it's all over fibre, apart from the converter pieces at each end.
Yeah, thanks.
Yep. Dante, Domain Manager. You're looking at that implementation and how is that likely to enhance what you already have?
So what I'm looking at the moment, it's very early days. I had a quick chat to some of the guys from Audinate over at ISE in Amsterdam in February, just pre-launch. Part of what we're doing here is allowing Dante network ports to be open in meeting rooms. So we're wheeling these consoles in and out of the rooms, which means the potential for having open ports into the system in each room it's a managed risk. The domain management system is going to allow a couple of things on that port. We're actually going to be able to control that by the back of house technician is actually going to be able to control which ports are open in the client-facing space. In the back of house space, we can then open and close access to different parts of the Dante network to qualification levels through our technician fleet. So the number of people who are handling the small stuff, as it were, in front of the customer can manage open ports in the room, but people managing the configuration of the global Dante network will have to be my systems engineers, and that gives us a bit more granularity of control there. Also, with adding and removing Dante devices, and I'm not thinking now in terms of where we are at the end of this upgrade process, but when I change all of our UR4D radio mics over to newer models, we're constantly refreshing our fleet, they will be Dante-enabled radio microphones. So adding and subtracting those from the DSP will be able to be handled through that system.
Another question.
Yep.
Power. You mentioned briefly UPS before. So what's the strategy for backup power for, first of all, this DSP and generally AV those systems versus the building itself? And obviously there'd be a diesel plant somewhere, but there would be, I guess, no break UPS, Emerson or something like that.
Yeah.
Right. So how does all that work, and how long will it run? Roughly.
Can't remember the timing.
15 minutes.
About 15.
Yeah. So there's enough UPS and it's battery UPS in each control room to keep the rooms, including the projectors.
Right.
So the projectors and all of the AV in the room, as well as in the rack, are all driven off the UPS.
Right.
We get 15 minutes run time prior to fail.
Yep.
We also have a couple of very, very large diesel jennies down in the basement.
Yep.
So that if we actually suffer an external power outage,
they kick in.
We're going to have the UPS keeping the system running for long enough for the diesel jennies to kick in.
Start up,
and then you can cut back.
And then we can cut back.
And they're duplicated too. So
that's right.
If one of them
if
fails,
one of those falls over, we've got another one in there as well.
And then in addition to that, there's a third one for the EWIS. And all the
the
PA.
emergency,
Yeah, the emergency
related,
system's separate again on top of that.
Yeah.
Very good. Thank you.
You had a question? Yes.
Regarding the plenary, is the upgrade complete or was it?
No, the plenary will go through the BSS upgrade over January. We determined it was going to take, if I recall from Paul Moore, it was 10 days to fully integrate the Dante system into the plenary. Trying to find 10 days in a row in that room is very, very, very difficult. In fact, even in January, which is our quietest time of the year, I've still got the sales people, bless their souls, pushing back and saying, "Oh, I'm sure we could find one show in the middle of your 10-day period." But yeah, don't worry, I'm saying no. But the reason plenary's held off so long is just access to that space is really, really hard.
I think when we did the Digital Vision
We
upgrade in 2014, the
did the same
plenary
thing.
was the same thing. It was
Same thing last
January
space.
2015 that we finished.
Yeah,
that
so
part of it.
always the last space to get into.
At the moment, is it 96 kilohertz?
No, right now, oh God, I'm trying to remember what the clock rate is on it now.
In the plenary.
I think it is.
Yeah, I think it is.
I think it is at 96 at the moment. Yeah, it's a bit hard for me to remember because right now, prior to this upgrade, the plenary hall is kind of running in its own. It does have the CopperNet system, so the results or the audio in there is put onto the CopperNet system, but the rest of the room is a completely isolated performance-based system. But I'm pretty sure it's running at 96K on ether sound.
And it's ether sound from the control room just out to the racks. The
To
rest
the
of it,
amps.
the rest of it is on the Digico fibre loop.
Yeah.
So because we've got Digico racks on stage, Digico racks up at the
Portable
up in the-
Digico racks.
portable
It's all
ones
connected
and-
by the Digico optical connectors.
Okay. Right. I think so.
I'm really having a run.
It's using a bit
If one of your customers wants a record of meeting,
Yes,
how do you support that? Can you give them video and audio streaming that's theirs and there's no
absolutely.
legal?
No, if it's their content,
Yes.
then we can record that and do record it as a matter of course. So we use a whole series of different recorders, whether they're Epiphan lecture recorders or Shogun, the Ronin SDI, embedded SDI recorders, depending on the quality level of what they're looking for in a recording. But we can record all of the rooms simultaneously, both audio and video streamed into our lecture recorders. What we actually do is we'll record the slide content. We'll put a camera image in a 4:3 aspect ratio. wherever we can find room on their slides. So in here would probably make a little box down here in the left-hand corner, and then embed the audio stream on top of that, both the source audio as well as the microphone audio. But then, of course, in the recording system, we've then got independent balance control. So,
okay, and commercially, if a record of meeting is taken, the person or the people that have booked the room may not want that to be made public. They'd want a copy for themselves. So
absolutely.
Do you have a signed agreement at the start?
We do not distribute any recordings. Yeah. We provide the customer with the recording, the person who booked that service, the owner of the meeting.
So that's totally managed.
We will manage that by giving it to them and them alone.
Right.
People who come to us saying, I just saw this fantastic meeting, show, conference, whatever, can I get a copy? No. The answer is, please go and see the organiser. They're right over there, and if you'll be able to discuss that matter with them.
Sure. Okay.
IT security question, and we touched on that as one of your reasons also for looking at Dante domain.
Port access. Yeah.
With bring your own device, USB sticks, third-party laptops, plugging into your network, all over the place. 1 million people coming through the doors.
Each of whom have...
What sort of products, hardware and software, do you have running to manage the threat landscape?
So our ICT team, and they actually sit sort of like, they're very close to us, but one step removed. We only allow ports open in the room that have VLAN separation between the customer side and the business side. So they don't get any access further beyond the switch based on the VLAN access on the port, further back into the business systems. So it's basically managed on the VLAN level. Obviously, we have a whole bunch of other background firewalls going on. We've got virus detection on all of our hardware, and our hardware, which we allow every customer to connect a USB key to, or a CD, or whatever virus-ridden device you turn up with. We run deep freeze on all of our hardware, which means when you reset it, it comes back to the fresh image. Okay. You can do a temporary install of whatever you like on the front end of it, and then as soon as I turn it off and on again, it comes back to the fresh image. And it is VLAN isolated again from everything else on the network.
Good, thank you.
Any more?
No, that's fine.
Thank you.
Thank you. Use his quota.
Right. More questions? No? No. Well, I'd certainly like to thank you both for coming along tonight and giving us a most informative session. These guys have got a lot more questions, but they usually do it after the show.
After we've gone.
That's right. So I'd like to thank you both, Matt and Michael, for coming along, and also for you accompanying the silent achiever at the back. We did have something to give you for you get rewarded. So I'd like you to accept these as some minor tokens.
No worries.
Of,
all right. Thank you.
I appreciate it very much.
To do that.
And we do. Thank you very much.
I appreciate the invitation.
Yeah. Thanks,
Thank you for having us here tonight.
Okay,
Thank you.
and